Here we have a momentum versus clock time graph. Lowercase p stands for momentum. We have a momentum of 1.7 momentums in kilogram meters per second at I've reversed these coordinates and I'm going to have to fix that. This should be 0.02, 1.7, and we'll cross that out, and this should be 0.05, 2.1. Sorry, now we have a momentum of 1.7 kilogram meters per second at a clock time of 0.02 seconds and a momentum of 2.1 kilogram meters per second at a clock time of 0.05 seconds. Let's interpret the rise and run of the graph. The run, as we can see, goes from 0.02 to 0.05, gives us 0.03 seconds. The momentum from 1.7 to 2.1 is 0.4 kilogram meter per second. So what is the slope of this graph? Well, the slope is the rise divided by the run, which is 0.4 kilogram meters per second divided by 0.03 seconds, and that's approximately 4.3 repeating kilogram meters per second squared. Now, what's a kilogram meter per second squared? Well, that's a Newton, isn't it? Okay, what does this indicate? Well, this indicates that the slope, which is change in momentum over change in time, appears to be equal to the force. Does that make sense? Well, it certainly does if you remember the impulse momentum theorem that says that the change in momentum is the product of the force and the time interval. So that we see that the slope here of a momentum versus clock time graph in this case is 4.3 newtons, and in general indicates the rate at which momentum changes, of course, the time rate of change in momentum divided by time, but it also then indicates the force, or the average force at least, between these 2 points. So that we can see average force as the rate at which momentum changes. And in fact, when you go to the calculus definition, the rate at which momentum changes is the force. Okay, so we have force equals dp over dt. The instantaneous force is the instantaneous rate at which the momentum of an object is changing. Now, in this case, we'd of course be talking about the net force on the object, and of course you've seen all that in connection with your study of the impulse momentum theorem.